Welcome to lecture series on data structures. In today's lecture series, let us discuss about breadth-first traversal in graph data structures. So before going to the topic, let us recall what we have seen in the previous lecture videos. So in the previous lecture, we have discussed what is a graph. So as we have seen earlier, graph is a nonlinear data structure and it contains vertices and edges. And we have seen the representation of graph. A graph can be represented in two ways. One is using adjacency list and other is using adjacency matrix and incidence matrix. Third is the type of graphs that we have discussed. So graph can be classified as cyclic or acyclic graph, directed or undirected graph, and weighted or unweighted graph. So these are the things we have discussed in our earlier lecture. Today, let us discuss why breadth-first search is required and how breadth-first search is performed and what are its application. So this is the this particular figure empathize the need for breadth-first search. Consider you are in an emergency evacuation process and consider if you want to spread or if you want to disseminate message. Consider if you want to find the shortest route in a Google map, and consider the situation where you want to find the friend who has lost in a particular building. In all these cases, you will perform the search in a level by level manner, which is called as breadth first search. And in case of computer science, a graph breadth first search is applied for traversing or searching for a particular graph. It is also used for finding the connected components in a particular graph. And if you want to find the shortest path, and if you want to find a bipartite graph, breadth first search is applied. And it is also used for performing level order traversal, as we have seen in tree traversal techniques in tree data structure. So this picture depicts the breadth first search algorithm. It performs node exploration in hierarchical levels, and it uses queue data structure for performing level order traversal, and it is one of the major important method for performing graph traversal techniques. So it explores the immediate neighbor nodes first before exploring the other nodes. This shows the working of breadth first traversal. So you will start the traversal by visiting one vertex at a time. So here initially I have started by visiting vertex A. So that particular vertex is inserted into the queue. Next, you will explore the adjacent vertices of A. Here the adjacent vertices of A are B and C. So once you have explored the adjacent vertices, that particular vertex A is removed from the queue and it is written in the output. Now, the next element that has to be explored is B, because this particular vertex is present in the front of the queue. Now, the adjacent vertices of B are C and D. C is already present in the queue, and now we have inserted D into the queue. So, since B is explored, it is removed from the queue and it is written in the output. Now, the next element to be, or the next vertex to be explored is C. So, adjacent vertices of C are E. E is written in the queue. So, C is removed from the queue and it is written in the output. Next vertex to be explored is D. Adjacent vertices of D is F. So F is written in the queue and D is removed and it is pushed to the output. So the next vertex to be explored is E. Adjacent vertices of E is F, which is already present in the queue. So E is removed and it is written in the output. So the last vertex to be explored is F, and adjacent vertices of F are D and E, which is already visited. So F is also removed from the queue and it is written in the output. So the breadth first search for this particular graph is A, B, C, D, E, and F. So if you look at the figure, breadth first search is performed level by level. In the first level, we have the vertex A. In the next level, we have vertex B and C. And in the next level, we have vertex D and E. And in the last level, we have the vertex F. So let me describe the working of algorithm once again. So initially you have to create an empty queue and a visited set. A vertex is added to the queue and it is marked as visited when the traversal process begins. Now this particular vertex will be removed from the queue when the adjacent vertices are visited. For every unvisited vertex, you will mark the neighbor as visited and it is added back to the queue so that the further processing can be done. This process is continued until your queue is empty. So once the queue is empty, it means all the vertices has been visited in a breadth first order. So if you look at this figure, the breadth first search is performed in level by level manner. In the first level, we have vertex A. In the next level, we have vertex B and C. And in the next level, we have vertex D and C. And in level 4, we have vertex F, G, and H. In level 5, we have vertices I, J, and K. And in the last level, we have vertex L. This is a hierarchy of BFS algorithms. It ensures optimal search by exploring the graph in an efficient manner. And it is used in identifying the connections in a network, and it is also used for finding shortest path in a given graph. And it is the most basic fundamental algorithm for performing graph traversal. These are the various applications of graph. It is used in social network analysis, where it is used to identify the connection between various entities in LinkedIn, for example. And in case of Google Map, it is used for finding the path from one place to another. And it is also used for navigation purpose. In case of web browsers like Bing and Chrome, it is used for web crawling and indexing. And in addition to that, it is also used in puzzle solving. It is also used in network broadcasting. It is used for performing GPS navigation and many other applications. So let us conclude with what we have seen so far. So initially we have seen what is BFS, how it is used for traversing or searching a given graph. And we have seen the BFS process where Q data structure is used for implementing breadth first traversal. And we have explained this breadth first search or level order traversal with the help of an example graph. And at last, we have seen the applications of BFS, which includes social network analysis, web crawling, indexing, and navigation in case of Google Maps. So now look at the assessment question. So here the first question is the data structure used in standard implementation of breadth first searches. As we have seen earlier, Q data structure is used for implementing BFS. And look at the next question. A person wants to visit some places and he starts from a vertex and then wants to visit every place connected to the vertex and so on. So if you want to visit a vertex, if you want to visit place and its adjacent places, obviously breadth first traversal is used or breadth first search is used. Like exploring a place, and also you will explore all the adjacent places. In that case, you will apply BFS. So the answer is breadth first search. So hope you understood what is breadth first search and its application is. We will discuss some other interesting topic in the next lecture. Thanks for watching.